For our engineering project, we picked a solar-powered night lamp by Caden Waln.
Marquez.
Jaimin Ellinghuysen.
And Neerah Lulu.
Introduction. The United Nations Sustainable Development Goals calls for an immediate action to aid in reducing the effects of climate change, provide accessible resources such as energy and water, ending poverty, and more. Problem identifications. Students' utilization for light at night, time for studying, small amount of energy equals a large impact towards climate change. Modular solar energy utilized to replace traditionally non-renewable electric-powered lamps. The ramifications of the problem. Affected communities are ones with power issues, health of individuals, safety of the community, and communication issues.
Our project mainly revolves around converting solar energy into light energy. So below are the criteria and key points that we looked into and considered in making the project. One of the main targets of this project is for accessibility to low-income individuals and communities. Money spent on electrical bills can be saved for other purposes. For example, in Bangalore, India, families using solar panels can save up to $100 per year. Adding on to that, there are also a lot of communities that have little to no access to electricity. So typically, they use candles or generators that can be a little bit pricey. So let's use candles as an example. More or less, a candle costs 45 cents per piece, which costs 4 cents per hour of burn. So in about 1.5 years, it would be cheaper to use solar lamps in the long run. Students prefer to study at night, and according to an article, 63% of students study at night, while the 37% prefer to study at daytime. In addition, to achieve the same lighting as a 40-watt bulb, you'd have to light dozens of candles and would emit about 10 times as much greenhouse gases as simply turning on a light bulb. Moving on to its impact on the environment, on the right is a chart showing the increase of heat trapped due to greenhouse gases, which accounts to 43% in 2021. Because solar energy is a renewable source, it helps in reduction of greenhouse gas emissions, a major factor affecting climate change. Solar energy also reduces the usage of electrical and fuel energy. There are also several major benefits to the environment. It reduces sulfur dioxide and nitrogen oxide, which are major atmospheric pollutants that cause climate change. It also reduces usage of water. When extracting and refining coal for fuel, excessive water is used during the process. So, using renewable energy like solar energy not only reduces consumption of coal and fuel, but also reduces the usage of water. Preserving finite resources. By using renewable energy, it helps sustain the non-renewable resources that we still have on Earth.
Existing technologies. Similar technologies to our prototype, such as a solar charging pole, is a standalone unit equipped with a 30-inch table with a rapid USB port, in which the stand is space limited. Constructed of stainless steel and finished with multiple layers of long-lasting UV-protected coatings, it also includes a controller to ensure maximum energy absorption. This charging spot ensures durability and sufficient electricity for the needs of an individual. A solar home system is a cheap and reliable electricity service that can be utilized by using solar energy panels. This system helps with the cost of energy by reducing the use of batteries and inverters, which also reduce the overall cycles that these batteries go through when being charged and used. A solar home system is composed of solar panels, a solar charge controller, batteries, and an inverter that helps convert the energy of a solar panel into the type of power that home electronics will use. Also, we have the battery system stations, which are one of the most cheap type of technologies that low-income areas use in order to meet their needs for some electricity. They consist of a panel, a solar charge controller, and a battery with connections for different types of devices. It is a method that poor areas have been using in order to obtain cheap or no-cost power. By most of the cases, the amount of power generated is not the correct one to meet the needs of an individual. A solar lamp, which is our prototype, there are also solar lamps out there in the market. These lamps are single piece equipment, meaning that if the battery or a solar panel or a cable is damaged, the whole lamp has to be replaced, but the technology does exist. Competitive advantages of our prototype. Financial. Given the circumstances of our current location, the parts of the prototype were bought in the United States, but our goal is that when we launch our prototype to the market, we want to obtain each of our parts from a supplier from a country where we can buy for a very low price compared from the prices in the United States. Not to mention that our prototype will be built by parts and will be replaceable by parts, meaning that if the battery stops functioning, but the rest of the prototype is still in excellent condition, there will be no need to buy a new lamp, but instead just replace a single part of the lamp, making our lamp more sustainable. Because the usage of solar energy and the option of having when to consume solar energy, with our lamp, individuals can illuminate their home instead of using their electricity, causing a decrease in energy consumption and also causing a decrease in the electricity bill. Comfort. Even though there exists other types of technologies that promote clean and sustainable power, communities with such as low-income areas cannot afford this type of energy most of the time. Our prototypes not only ensure a comfortable price, but also ensure comfortability when it comes to the space of a person. This lamp can be used anywhere and at any time. The size and weight of the lamp is perfect enough to be carried and to be left in any sources. For the location, anyone with our prototype can use it in any part of the planet. Every part of the planet gets sunlight, and because of that, no matter where a person is, the lamp will always be helpful. The installation for our lamp is easy. Our lamp does not consist of a lot of components. It's easy to install and is easy to be replaceable. Not to mention that the batteries and solar panels can be used hundreds of times and can be recharged hundreds of times, meaning that our lamp can be used for more than a year without having to replace any part of a prototype. And because lithium batteries can be recycled, our prototype ensures sustainable and clean energy as possible.
Okay, so our design. From our concepts as well as our background research, we came up with the design which houses 8 main components. As you can see in our sketch on the right, we have focused 8 main components, including the light bulb socket, the ring clamp, the lamp base, switch, battery, controller, circuit wire, the L-shaped topper, as well as the solar panel, of course. Because many of our design aspects were used from current products which already exist for different applications, such as our lamp base and ring clamp, which are used for scientific applications, our cost was rather high. It came out to $86.78. However, relative to other alternative solar panel products on the market today, it is reasonable. Additionally, the weight of our product is quite light, meaning that it is between 1 to 2.5 pounds, depending on what requirements you need. So since our design is based off of a modular concept, meaning that if you do not need the lamp base or you do not need a ring clamp, or perhaps you already have a solar panel currently and you only need the circuit controller, switch, battery, and of course light bulb and socket, it is possible to do such as only those items required. However, our battery life is another highlight. With a life of 7 hours, our capacity allows for a complete usage of nighttime work, as well as with a 14-hour recharge time from 0 to 100%, it is plausible to utilize day after day if necessary. With our cycle life of 3,000 cycles, it can last anywhere between 7 to 10 years based on usage, and all the durability of our products is capable. The dimensions of our product are reasonable as well, with dimensions between 6 by 4 by 18 inches, meaning that our product is comparable to many others. When it is sunny, it is outside and it will be charging. When it is night, you can bring it inside, turn it on with the switch, and use it as a regular lamp with the battery power. And then, of course, repeat the cycle during the day and usage at night. Although we were unable to fabricate our design due to different constraints, we were able to model our design in CAD, as you can see on the right. With all the same components utilized from our sketch, we can see that realistically a design is very feasible. As well as some estimates from different calculations, we believe that a national potential cost saving over the lifespan of this product can be at least $170 million. Furthermore, a global impact for 220 million students as opposed to the national 17.8 million students can be seen to be a much greater impact over a global standard. However, certain failure points include the clamp, the battery cycles, as well as durability, of course, throughout its 7 to 10 year lifetime. In conclusion, we can see that the utilization from our light at night, which is a major requirement for students, can be solved through renewable energies, helping solve the UNSCG's number 7 and 11 core issues. As well as, of course, with our prototype modeled in CAD, we can see it is a feasible working prototype. However, although we were not able to build it, we are unable to see unforeseen circumstances that could affect negative results. However, the product met all the group's established requirements, meaning that it, of course, lasted greater than 4 hours of life cycle time at night. Additionally, with the course of using a greater solar panel, it could reduce the potential of longer exposure required to charge fully. In the future, we look to establish this with eco-friendly prototypes with more eco-friendly batteries, as well as smaller but powerful lights, a base that is made up of recyclable materials, as well as being water resistant, and attachment options, which could allow for more versatility in places with high winds with a turbine on top, or of course high humidity and humidity resistance.
For future recommendations on people taking over our prototype, we highly consider build more lamps using other types of clean energy. We would like for others to take our prototype as inspiration to build a similar type of work, such as other solar-powered home electronics. We would like people to use our prototype as guidance, keep the price in a lower range, think about the community, the location, and the economic status of people, like where they live, how much they get paid, and overall their situation. And finally, we would like other people to really look into the durability of our battery. We would like other people to make our prototype more efficient for the community. And these are our reference. Thank you for your time.